So advances in artificial intelligence, and most especially generative AI, have been coming fast and furious. But what are the risks of this technology? What are the risks of this technology developing so quickly? What checks and balances are in place, and how can we use AR for social good? How can we protect individuals and communities against its misuse? And what role will AI play in the metaverse? Please join us. Thank you for joining us for this insightful look into the practical, ethical, and legal issues around the use of AI in the metaverse. So, Matt White is CEO of Berkeley Synthetic, a research group focused on applications of AI in physics, natural phenomena, deep generative learning, autonomous agents, and simulations. He is a member of the faculty at UC Berkeley, teaching grad students generative AI, computer vision, and deep learning at the School of Information. Matt is the chair and co-founder of the Open Metaverse Foundation and also a chair at the Metaverse Standards Forum, where he leads the Digital Asset Management Working Group focused on interoperability, portability, security, and ownership of 3D digital assets. Matt is passionate about building an open standard framework that leverages decentralized high-performance computing, applications of AI and blockchain in massive online multi-user simulated environments, and exploiting the power of neural methods and generative AI to help build the metaverse. Let's welcome Matt to the stage. Take it away, Matt.
Thank you. Thank you for that intro. That was probably about half of my presentation right there. So thanks for getting that off my chest. So yeah, my journey to the metaverse sort of began in the mid 2000s at the height of the Linden Labs Second Life craze. Like some others, around 2006, to the chagrin of Philip Rosedale, the Second Life community reverse engineered the Linden Labs protocol. And out of that, several open source projects developed out of the foundation, as well as the Open Simulator and Hypergrid projects. At the time, the community began creating virtual worlds built on Open Simulator, which we called grids back then. And those virtual worlds were interconnected with persistence layer that allowed users to teleport between virtual worlds, keeping their inventory and digital assets with them. Sometime later, an IETF working group was created called VRAP, which intended to standardize metaverse protocols. But it turns out that all of these initiatives were ahead of their time, and interest in the metaverse waned in the mid-2010s. Fast forward to 2019, there was a renewed interest in the metaverse. This was a few years before Mark Zuckerberg renamed Facebook to Meta. And here we are again, building the open metaverse. Except instead of a small community, we now have a large army that are all working towards the realization of the open metaverse. Next slide. We able to advance the slides?
Is that your slide? You look in front of the video. You have that.
I've switched to headset. Is this any better?
Yes.
Could we advance the slides?
Yeah, the next slide, challenges. Matt, is that your slide? Hey, Matt, I'm going to jump in here to help you out. So you can see the challenges slide is on. Yeah.
I do not see any slides showing up in here.
So yeah, your slides are actually up on the virtual world as well as live stream, or on the challenges slide right now.
Okay, looking at the board, I do not see that, or the teleprompt. It's still on the first slide.
Oh, okay.
The day one human rights in the metaverse.
Oh, I see. We can
Is anyone actually seeing any
Yeah,
other slide?
we are actually seeing the challenges slide. I'm happy to coordinate with you.
Sure.
Which slide do you want?
Can we go to the AI in the metaverse slide, which is the first
Okay.
one after my intro?
Yep, that's where we are.
Okay, perfect. All right, let me go back around this way. All right. And everyone can hear me okay?
Yes, we can hear you great. Thank you.
Fantastic. All right, so it's really unequivocal that AI will play a central role in the development and the operation of the metaverse. And I don't say this because AI is my professional domain, but because AI in its varying forms is very powerful. And I believe that we have only scraped the surface of what we can do with AI. There certainly will be new innovations within the field of AI that will supersede the current state of the art and be even more powerful. If you haven't been living under a rock for the past year, you'll have seen the explosive advances in the mainstream interest in generative AI. Although generative AI has been around since Ian Goodfellow's seminal paper on generative adversarial networks in 2014, incremental improvements, most especially in image generation, have reached a point where outputs are both spatially accurate and realistic enough to be applied for meaningful applications. Generative AI is similar but distinct from conventional discriminative modeling techniques. Through supervised or semi-supervised learning with large data sets and large optimized models, we are able to generate synthetic data which can take many forms, from simple variables drawn from a population distribution for data augmentation purposes, to the generation of novel two-dimensional images, text, music, short videos, and now 3D digital assets. In the metaverse, we can imagine that AI will not only play a role in the creation of virtual worlds and digital assets, but in many other applications as well. From neural methods used for fluid, fabric, hair, and other environmental simulations, including life cycle emulation, simulated natural phenomena, bringing life to non-fabric characters, and training autonomous agents used in robotics and autonomous driving. Most certainly, conversational AI, universal real-time translation, and generative text will be realized through large language models, natural language processing, and synthesized audio. AI will be highly relied upon for less overt applications, like AI arbiters, who handle transaction disputes without the involvement of the central authority, to applications in safety, where moderating AI agents patrol virtual worlds, flagging offensive actions and speech. We may also imagine AI gatekeepers, preventing entry of bad actors and inappropriate or illegal content from entering virtual worlds. Truly, the applications are quite limitless. Next slide, the benefits. There are no doubt significant benefits to using AI. Applications of AI can reduce barriers to entry for those who do not have the training and tools to create 3D scenes and asset models. With generative AI creator tools, the creator economy will be empowered to be able to rapidly develop content in the form of images, 3D objects, blog posts, and so forth. AI can automate tasks where humans would take substantially longer to complete, or it can remove human-induced bias and remove human error from the instrumentation. We can glean significant insights into data and predict future outcomes or prescribe actions using data science in situations where conventional analytics just don't stack up. AI doesn't sleep or have business hours, so we can maintain continuity of services across time zones without interruption. And AI can be used to improve quality of life, advance education with adaptive pedagogy, identify health issues, and predict future ailments, as well as perform drug discoveries in synthetic environments, reducing the need for animal and human trials. AI can also assist healthcare professionals in making more accurate diagnoses. A 2020 study from the Journal of Nature showed that AI was more accurate than doctors in diagnosing breast cancer from mammograms, which can ultimately save lives. When paired with robotics, AI can reduce potential dangers for human workers, reducing workplace injuries and strenuous activities. Next slide, please, the challenges. But the same technologies that are used for good can also be misused intentionally or unintentionally. They can be weaponized, and they can be used to create power imbalances and subvert others. Some of the major challenges with AI fall into the responsible AI domain. These are the areas of trust, authenticity, bias, transparency, and explainability. These areas cover the entire value chain for AI, from AI research to quality of data, how models are trained and applied, to how they are employed by businesses and organizations, and for what purposes. When new innovations are made in the AI research community, the only way to be truly transparent is to release training data sets, the model and its weights, and the accompanying paper. However, this rarely happens in practice. The majority of new innovations only have a research paper released and nothing more. So this is the opportunity to review and audit claims made by the paper's authors, as well as identifying potential issues with the research. Generally, this happens because there is a concern by the organizations behind the research that the work will be misused and create liability for them. But bias can only be identified if the research can be reproduced using all of the exact same hyperparameters and training data that the model was trained on. And this occurs both in research and in the application of AI in businesses and organizations. Trained and deployed models used in research applications need to undergo a review to account for the potential bias and explain exactly how models were trained and how it works. With AI becoming more pervasive and moving towards a more integral part of our everyday lives, functionality normally conducted by people and replaced with AI disrupts the job market. Education is rarely ahead of the curve, and retraining to create new ML engineers and data scientists that understand the state of the art in AI takes time. This ultimately creates a talent vacuum while the workforce adapts. However, the portion of the population whose jobs are displaced are often unable to adapt to the evolving technologies, especially when it comes to the service sector, and subsequently this sector becomes saturated with people looking for work. When AI is misused, it can be extremely harmful. In the hands of hackers and scammers, it can impact economies and the financial well-being of individuals and organizations. But the biggest harms in AI are not always intentional. And there are plenty of examples where bias, racism, classism, and other discriminatory factors have played a role in harming populations. For example, in 2019, researchers found that an algorithm used on more than 200 million people in the US to determine their healthcare needs heavily favored white patients, because the model was trained on past healthcare costs. The rationale was that healthcare costs are the highest factor in determining healthcare needs, and since non-whites were less likely to have healthcare or adequate healthcare coverage, it determined that Black patients did not need the same degree of care. And the most prominent example of abuse in AI is the COMPASS system. This AI-based system used by the US courts to predict the likelihood that a defendant would reoffend. The model ended up predicting that twice as many Black offenders would be repeat offenders versus white offenders, which was not statistically supported, and it created an obvious bias against the Black population within the legal system. Next slide, please. AI ethics by design. So what are the possible solutions? How can we mitigate harms and abuses due to AI, whether intentional or inadvertent? And who is responsible for ensuring that AI is used only for good? It all starts with AI researchers. They are responsible for developing new methods and new applications of AI. The onus falls upon them first to practice responsible AI, which is an ethics by design methodology. There are quite a few similar AI ethics by design models out there, but I rather like the Data 61 ethics framework. It is built on 8 core principles, and although it is not specific to AI research, I do think it does a good job of covering the areas that need to be addressed in developing new AI methods and applications. Above all, it stipulates that you must not do harm. This means designing systems that do not harm or deceive people and should minimize any potential negative outcomes. The framework also covers regulatory and legal compliance. AI systems must comply with all the relevant laws, regulations, and government obligations. This is an important principle, but it is also often ineffective because legislation governing AI is almost non-existent in the US and around the world. So we must be good stewards, and even when the law doesn't exist, we must use our best judgment. Fairness is also an important principle. AI must not result in an unfair discrimination against individuals, communities, or groups. They must be free from training biases, which are often the source of bias found in poorly cleansed data. Contestability covers the process to remedy issues of fairness, bias, harms, and violations in AI, where accountability holds people and organizations responsible for the impacts of algorithms they develop or deploy. Transparency and explainability are also very important. If you cannot adequately explain why your algorithm does what it does, then it should not be employed. Transparency means that you must inform users and stakeholders when you are using AI and what it does and how it achieves those outcomes. Privacy protection ensures that any private data is protected, anonymized, kept confidential, and stripped of attributes that could lead to bias or harms. It also requires close adherence to privacy regulations that apply to a particular jurisdiction. And finally, generate net benefits covers ensuring that AI always produces results that outweigh any potential costs to those affected by the algorithms employed. Next slide, AI ethics in the workplace. Downstream from AI researchers, we have the organizations and individuals who apply AI. In the development of applications of AI, data engineers, data scientists, ML engineers, operations, and truly anyone involved in the process, including executive leadership, product development, and the business bear responsibility for ensuring ethics are applied adequately and responsibility in an organization. From conception to production, there is an AI value chain that has 6 principal areas that have their own idiosyncrasies. The value chain consists of problem definition, data collection, data storage, data preparation, algorithm programming, and application development. In addition, operations and data and model lifecycle management are also very important to complete the ecosystem. One of my favorite frameworks for applications of AI in business is the Sage Group's framework for ethical AI, displayed here. It prescribes a set of business actions that consist of actionable activities that ensure that AI is used for good. It starts by recommending an organization establish a governance framework for AI, to create a board and assign accountability to its members. It requires that ethics be a part of a company's AI strategy and that all stakeholders be mapped out in the complete AI value chain. It also prescribes accountability for AI-based applications, prioritizing trust and credibility, keep a human in the loop for AI-driven decision-making, consult ethics experts, establish QA standards, and ultimately monitor the performance and risk of AI applications. The framework also enforces building trust and transparency. This entails explaining how AI is used in the organization and why. Create explanations that use common vernacular. Share success stories and positive outcomes, but also recognize and remedy failures to meet the principles of the framework. And finally, empower your workforce. Map your skills to roles and level up your talent. Invest in the workforce of tomorrow and ensure that new talent understands and adheres to the AI for Good framework. Next slide, please. AI ethics for users. The responsibility for ensuring ethical use of AI doesn't only fall on the shoulders of those who create, train, and deploy AI algorithms and applications, but also on those who use the technology or are consumers of it. Oliver Feldwick from the marketing company The Partnership has created a 4-quadrant framework of intent versus outcome. This framework is straightforward and simple, but covers the considerations in applying AI ethically. Unethical usage covers the intersection of bad intent and bad outcomes, and this area is to absolutely stay away from. Nobody should be in this quadrant and applying AI directly or through the usage of tools and systems, uncategorically. On the opposite side of the spectrum, we have good intent, and good outcomes. This is the AI for good region. However, that does not mean that there are not ethical considerations. One must consider whether or not the application of AI creates unfair advantages that could harm or marginalize others. And in the domain of bad intent but good outcomes, and the good intent and bad outcomes, we also want to stay away from these quadrants. Bias derived from bad data or the unconscious bias of the user can cause unintentional harm. And even though intentions may be good, they can lead to unintended consequences through inadequate insight, transparency, and explainability. Next slide, please. Metaverse Code of Ethics. I'd like to conclude today's presentation by reviewing the Metaverse Code of Ethics, which is based on the ACM's Code of Ethics. This code is intended to govern the actions of those who are responsible for designing the underlying technologies that will be needed to realize the vision of the open metaverse, as well as for those who build in and for the metaverse. The Metaverse Code of Ethics has 4 pillars. Firstly, you should promote the well-being of yourself and others. This entails design for privacy and security and honor confidentiality. Maintain controllability of technologies, especially AI. Consider all risks and foster public awareness of consequences. Be fair and take action, not to discriminate. Let your work be inclusive and representative. The second pillar is practice openness and transparency. Invite diverse stakeholder input and encourage discourse. Promote values of autonomy, transparency, explainability, and trustworthiness. The third pillar is honor the work of creators. Respect the work required to produce new ideas, inventions, creative works, and computational artifacts. And the fourth and final pillar is enforce ethical behavior at all levels. Make ethical reflection and practice the standard, and have a bias for action when the code is not adhered to. Next slide, please. So thank you very much for joining me today. If you have any questions or just want to connect, please feel free to reach out to me on LinkedIn or drop me a line. I'm assuming this slide has the QR code on it, and you're welcome to scan that. That will take you to my website, and feel free to reach out to me at using any of my contact details. And thanks again for attending.
Yes, thank you, Matt. Thank you so much. The screen, I apologize you can't see it, but it does have the QR code and all the contact information on the social media platforms. So we have a couple of minutes. If you do have a question for Matt while he is here, we should we're ready for our first question.
Maybe someone could raise a leg.
As an advisor, the diversity and inclusion advisor for XRSI, a lot of what you mentioned, Matt, and went over spoke directly to me and our mission and my role as an advisor for XRSI, in addition to the CyberXR Coalition. Sometimes people need to be reminded some of the principles you discussed in the presentation today. Other times it may be new for others, especially those who may not have engaged with, as you mentioned, the stakeholders who bring that diverse perspective to the table when we're trying to determine codes of ethics and things of that sort, specifically for creating the best metaverse that we can. So I appreciate all that was brought to the attention of the attendees today. And I believe we do have one hand that is raised. Go ahead and ask your question.
I just heard, I'm with the XRSI, I'm Ryan Cameron.
You can move closer to the stage. We can probably hear you better. Thank you so much.
So I just came from the OpenSim conference, which was pretty cool as well as this. And I heard you mentioned OpenSim and Hypergrid at the beginning there. So I was just wondering if you still had that in mind, or if you were still looking into that. The question of AI certainly came up a lot over there and stuff.
Yeah, yeah. I haven't been too involved in and OpenSim still exists, and Hypergrid, and those technologies still exist. I think, unfortunately, a lot of folks don't know that history, especially with so much interest in the metaverse now, and what folks have faced the same challenges going back 15 years that we'll be facing going forward. And so I'm not sure what was discussed with AI at the conference, but I presume a lot of it is around autonomous agents and those sort of applications.
Yep.
Yeah, and at the end of the day, what I would say is that the onus doesn't just fall on the researchers. Like I've outlined here, if you're a consumer or user or byproduct of AI, you have to be responsible in its use as well, right? And so it is a trust system that works from concept down to execution.
Once again, thank you, Matt, for your presentation. Yes, your information is listed on the screen for those that do have further questions. Thank you again, Matt. Let's show him some love with emojis and accolades as we prepare for our next presenter.